Hello, my name is Joshua Patel, and today I will be presenting my project about wetlands, well overpumping, and oil, and what these all have to do to the environment. So, my first topic is why is overpumping of wells an issue to wetlands or general environment, but mostly wetlands? So, overpumping groundwater from a well can cause a depression in the earth where a giant bubble of oxygen will be in the ground, and this will cause water to level out or decrease in general. So, if there's a stream or a river that has slow moving water, and the water under the ground or the water tables will have to lower to go and fill up the bubble that is being caused by this overpumping of water in the well. And this can lead to many issues, like for wetlands, it can cause the issue of where the water level will lower, where the plant's roots won't be able to take in enough water, because plants in wetlands typically require lots of water to maintain their viability or life. So this lowers the water table, potentially destroying wetlands forever, or at least until recharge comes or water recharges, which can take a long time and can lead to plant loss or permanent damage to a wetland environment. So, as engineers, we need to find a way to prevent this, which there are millions of possible ways, which is forcing recharge via water tanks and movement of water. But there's a quite simple and effective solution. We have these giant dams that allow water to go through and where. Or we have where a canal where the water must be lowered for a boat to go due to change of water level. For these, we can create walls around the wetland, which will stop the water being sucked out of the wetland, but not of the nearby areas. But also, we could create valves or little doors at the bottom, like a dam, and let water pass through if the water starts to overrise near a wetland. This solution provides an effective and cheap and not really overpriced or detrimental to the environment. It will take a little bit amount of engineering to dig a wall down to the closest layer of sediment that doesn't allow water through, which can has been is a few hundred meters deep. But it's not like we're just making a concrete wall to prevent this, and it's proven to work in multiple of situations, and it's also used in water environments where we need to increase boats or lower the water of where boats are so we can do repairs. It's like that. We're allowing the water pressure to go down in one area, which is not the wetland, and if the wetland needs to have water decrease in the tables, we open the doors, allowing for the excess water to go through. It's a simple way to maintain water levels in a wetland. So, for my other issue, which is a different topic, is what does oil have to do with wetlands? Or what does the contaminant known as oil have to do to wetlands? People over drilling oil or oil being excessively pumped out of the ground can cause issues in safety where cuts are caused and people don't care about how much they're doing, they just care about how much oil is. This can lead to the creation of oil spills or large amounts of crude oil leaking into the ocean. Or, in general, companies sometimes just dump oil directly into the ocean because it's a cheap and effective way to get rid of their byproduct, which they don't need or can't make money off of. So, this oil, it can go into a wetland or a coastal wetland that is along the ocean, and the oil can go into, and due to the oil's properties, it can block sunlight from reaching the roots, which isn't the big issue it causes. It causes starvation of the oxygen's roots, where it stops the top petals of allowing oxygen to get to the bottom of the roots, causing oxygen starvation, which leads to the death of plants and a lots of stress on these plants. And this isn't good for an environment that requires lots of plant life. Because if there's a lot of stress on the plant life, it will lead to massive loss of life in these wetlands, which is not good for the environment. Overall, this would be a major detriment if large amounts of oil was to spill into a wetland, which is why we need increased safety laws on oil. Next slide is for this project, we had to create a simulation of a micro wetland to simulate what happens if a possible contaminant was to enter the environment, or what's a possibility if a substance was to happen to enter the environment, or just what in general happens in a small wetland on a scale where we're able to observe in the environment where we have to be thanks to COVID-19. So, for this project, we were first required to make an on-shape design, which was to be a model of what we wanted our thing to be, or what we wanted it to look like when we're done. So, for the on-shape design that I created a on-shape design that can show what a tube would be, or a well would be into a wetland, with the three major layers that we had to include for our project, and the water included in the plastic bin that we were given for this project. This first layer where it's bright yellow, this is to represent the dirt, or the lighter the level, the more easier it is for water to slip through that region compared to the others. So water is generally able to go in and out through this dirt. And this level is the gravel level. It's also generally easy to go through, but it won't be able to. And this is the sand level, or what is represent our solid level of where water is not that generally supposed to go, or it's very hard for it to go. And so during the simulation, we are supposed to pour water here, and it's supposed to go. And we're supposed to put plants or cotton imitations of plants and see how the water moves and affects through the wetland. And this is generally what it's supposed to look in theory. But first we need to get the materials done for. So the materials I used for my project is sand, which is to represent the bottom layer, gravel, which is to represent that medium level, and dirt, which is created to show the top layer of which we would walk on and see. And the cotton swabs I use are to show how plants absorb water and move the water up and down, could be seen as like general plants, or plants that you have the roots under the water or in the earth and have the top of the plant coming out of the earth. And then we have the most important of the simulation, water. So here's the steps that we use to create this wetland imitation for the project. For our first steps, we had to actually put in the layers. For the first layer we put in was the sand and packed it in hard at the bottom to show our bottom layer. And then we put a gravel, which is very thin at the top where the dirt was supposed to go, and more heavy near the middle to the bottom of the slope. And then we had the dirt on the very top and not really in the water to show generally where we would put the dirt. For a second, we had to add the other things, or our way of measurement and the plants. So we had to add a tubing system, which one was supposed to be in the deep end at the bottom of the slope, where the water was supposed to be on the bottom of the slope, like this. The bottom of the slope. We had to have one tube here, and one tube as shown in this model here. And so these that's what the tubing system would do. And the cotton swabs, as I stated before, are there to show plants and what the plants are meant to do during this project. And the third and final step of how to make this micro wetland is to pour water slowly into the box to show that how the water's in the wetland. For this, these are some of the pictures from my project. As you can see, when we pour, the dirt kicked up a little bit at the bottom, but you can still get the generalization idea of that water moves through the wetland. And after seeing, the water didn't really go through the sand. It didn't, as it was supposed to be, showing how it's supposed to be rock. But it was able to move through the gravel and through the dirt very easily because of how not compact those two layers were. And through the project, you could see the cotton swabs. They slowly move the water upward as the plants are sucking the water out of the dirt and gravel layers and moving them towards the top of like what would be the leaves of this micro wetland, and it showed that the plants could dig the water from the bottom of the tub or micro wetland and pull them to the top, saying that the water was able to move through the dirt and gravel layers. So my analysis of this micro wetland was that during the simulation, the water moved up through the plants and moved through the gravel and dirt layers very easily, but not the sand as much, showing that the sand was supposed to be rock. And so near the end of the project, there was a little too much water, so it muddied up the dirt. But it showed that it was able to move through because it was also reaching in through the gravel layer, but not the sand because it was too compact. And overall, this micro wetland showed how if an oil was to possibly get into the water, it wouldn't just stay in the water. It would be in the dirt and plants and roots that could affect for a couple meters or a few miles if it's a big water. Thanks to the water tables, the oil could move through the dirt and go to trees nearby or plant life. The major problem. And also, with the wells and the overpumping of wells, it can show how wells can take the water from these wetlands because the water is simply able to move through the dirt and gravel layers of this project. But overall, this project showed how important it is to think of water as these wetlands as major things we need to be concerned of, because a major cause that happens to them could lead to the destruction of wetlands. And wetlands aren't these things that are just unstable and we need to worry about and protect them. They're actively helping the environment, which they can purify water, so we need to focus on protecting them. Overall, this project was a very eye-opening experience to what we need to, as a human species, to prioritize, and that we need to put more focus into taking care of this nature, because this nature can protect us and protect our children and the future. Overall, this project was one of my favorite, and I do believe it has taught me a lot of what I need to keep my prioritize as an engineer. Thank you.